Hi guys, so we are going to talk about today is about problems of finding moment of resistance. In my previous video I mentioned about three cases in the section of a beam, how we have to find the neutral axis depth to the depth of the beam ratio followed by the corresponding moment of resistance. Now in this video we're going to look into the problems of how to find the moment of resistance when a section of a beam is given. This is the first question. Determine the neutral axis of a beam 250 mm into 400 mm. 250 mm is the effective width and 400 mm is the effective depth. If it's not mentioned effective or any cover is not given, we'll assume it to be the effective depth and width is given. Reinforce with 3 bars of 20 mm diameter steel. Also check for the type of section. Use M20 concrete and Fe 415 steel. Alright, the question is we have to find the neutral axis, that is XU. And we have the beam section, the number of bars with the diameter. We have to also check the type of section of the beam, and here the what type of concrete and what type of steel is used is also given. Okay, first let's draw the information. It's not necessary, but it will be more easier to check out than reading the whole question over again. So I drew a rectangle. In the middle I've written Fe 415 and M20. That is, M20 is the concrete used and Fe 415 is the type of steel used, with 250 mm width and 400 mm width. The effective depth is still the center of reinforcement. That is the where the bar is placed, till there is the effective depth. Otherwise, if you take the whole rectangle depth, that is the overall depth. Here the effective depth is, and which is what we need to find the neutral axis. Okay, the first thing when a question is given, you first write the given things. Now you draw out the question, whatever is given in it. Now we'll written in the form of that. First we write the given things. First we write the beam section with the B into D, that is 250 mm into 400 mm, where B is 250 and D is 400, so small letter D. Number of bars is 3. 3 bars is used with its diameter 20 mm. Where M20 means the value 20 and 415 is the characteristic strength of the particular material used. Here for concrete we write the characteristic strength is denoted as FCK. FCK is equal to 20 Newton per millimeter square, and for steel it is Fy 415 Newton millimeter square. Now we go into the ratio of the neutral axis depth to the depth of the beam equation, that is the effective depth of course, which is given in the code, that is IS 456 2000. We know that XU by D is equal to, this is the equation, it's given in the code. XU by D is equal to 0.87 Fy AST by 0.36 FCK BD. Okay, we have effective depth D, Fy, FCK, B and D. Now we need to find AST. AST is the area of the steel provided. Here what it the when we see the front view of this beam, that is a section, we see that it's a circle. What is the area of the circle? Pi r square or pi d square by 4. That is the area of one steel bar. We have 3 steel bars here, so when we multiply, we substitute all the values in the given equation. This is the given equation. XU by D is equal to 0.87 Fy AST by 0.36 FCK BD. We cancel out D here, since we only have to find the neutral axis depth. XU is equal to 0.87 Fy AST by 0.36 FCK B, where D and D gets cancelled out on either sides. Substitute the values and we'll get the value 189.05 millimeter. Okay. We found out the neutral axis depth. Now we have to find the maximum neutral axis depth. Since we have to check the type of section used here, so the condition to be fulfilled to find the section, the first condition, since moment of resistance is not required here, we just have to check the first condition, that is the three cases with XU and XU limit, where XU limit is the maximum neutral axis depth. So from the IS 456-2000, which is the code that we are using for this subject, XU max, and for the steel uses for FE 415. For each different type of grades, there are different values for XU max. Since FE 415 is used here, XU max value will be XU max by D, or XU limit by D is equal to 0.48. And XU max or XU limit, in some textbooks it's mentioned as XU limit. Here I've used XU max. XU max or XU limit is equal to 0.48 into the depth of effective depth of the beam, that is 400, and we get 192 mm. When we compare both the values, we see that XU is less than XU max. In which case is XU less than XU max? When the section is under reinforced. Hence the section is under reinforced. So we have this was the first question. First we found out the area of steel, we multiplied it by the number of bars, then we found out XU, the neutral axis depth, then we found XU max or XU limit, then we compared it, and we see that we checked the three cases, it fulfilled the first case, XU less than XU max, which is the, and we also found the type of section, which is under reinforced section. Okay, this is the second question. Determine the moment of resistance of a beam 250 mm into 350 mm. The area of steel is of 3 bars with diameter 12 mm, which is placed at a distance of 40 mm from the bottom. Use M20 concrete and Fe415 steel. Okay, we have to find the moment of resistance here. Obviously, neutral axis depth comes into play here, as well as we have to check three cases on which type of formulae we have to use to find the moment of resistance. Okay, it's mentioned here, it's placed at a distance of 40 mm. 40 mm is actually the cover of the beam. Below the reinforcement, it says distance of 40 mm from the bottom, that is at the after the bar is placed at the bottom here. So that means in my in the previous question I mentioned that if a cover, the value of a cover is mentioned, or if it's not mentioned effective, if it's not mentioned about anything in the question, we consider it as effective. But since the cover is given, the depth given to us is the overall depth of the beam, and we have to minus the 350 mm, minus the 40 mm from 350 mm, and we'll get the effective depth 310. And here M20, 20 Newton per mm square is a characteristic strength of concrete, and here the steel used is Fe415, where 450 Newton per mm square is the characteristic strength of the steel bar used. Okay, this is the diagram that I've drawn out from the question and all with the given details. Fe415 M20, 50 mm, then here 350 mm the overall depth, and here the small cover 40 mm is given. We have to find the difference between 350 mm and 40 mm, and we'll get the effective depth 310. Substitute all the values in the equation. XU by D is equal to, this is the equation, 0.87 Fy ASD by 0.36 FC KPD, and we substitute it and we get 68.05 mm. From the IS code we have to find, since we have to check out which section is, we don't have to actually check out the section, but to to know which formulae to use for the moment of to find the moment of resistance, we need to know which section it is. So from IS code we get the value of XU max or XU limit by D, which is 0.48 for Fe415. We then multiply it with the effective depth and we get the value of XU max as 148. Hence XU is less than XU max. That means this case 1, this section is under reinforced. That means the formulae for mu limit or mu max is 0.87 Fy ASTD into 1 minus AST Fy by BD FCK, and we calculated 0.87 into 415 into the effective depth into 1 minus the area used here, which is 339.29 into again 415, and the denominator is divided by 250 into 310 into 20, and we get the value as 34525 45.39 Newton mm, which is 34.525 into 10 raised to 6 Newton per mm. Newton mm. So in this question we have to find the moment of resistance. First we have to find the area of steel, then substitute all of the given values as the also the value of area of steel into the XU by the ratio formulae, and we get the value of XU. Then from the IS code we use the equation from the IS code of XU limit or XU max. We find the value of XU max and we compare it and we get what type of section is. Here it is the under reinforced section, and with that, in that section we use this formula to find the moment of resistance, which is 0.87 Fy AST into D into 1 minus AST Fy by BD FCK. The third question, determine the moment of resistance of beam 300 mm into 550 mm effective. Effective is mentioned here, so the width and the depth is effective, so we don't have to subtract it from anything. The beam here is reinforced with 1963 mm square of steel in tension zone. Here we have the area of steel of all the given number of bars. Since the number of bars is not mentioned here, they have given us the area of steel directly. Use M20 concrete and Fe415. So also comment on the design of the beam. Okay. We first drew out the given details here. Fe415 M20, area of steel is 1963 mm square, 550 mm effective depth and 300 mm effective width. We write out the given details. Beam section is 300 mm into 550 mm. AST value is directly given, so we don't have to calculate it. FCK value as well as the Fy value is also given in the question. We substitute the values in the equation. XU by D is equal to 0.87 Fy AST by 0.36 FCK BD. We find the value of XU, which is 328.12. Now from the IS code we check the XU max value or XU limit value. So from the IS code 2000 for Fe415, XU max by D is equal to 0.48 and XU max value is 264. XU value was 320, right? So that means XU is greater than XU max. Therefore, it is an over reinforced section. when it is an over reinforced section, we have to redesign it. There's a procedure for redesigning, but here they only have mentioned to find the moment of resistance. In the over reinforced section case, if we don't redesign it, what's going to happen is that the failure will take place without warning and the building will collapse. So we have to find the moment of resistance before collapsing. That is, for example, say the moment of resistance before collapsing was 250 or something, and the moment, and since it was an over reinforced section, it must have exceeded to 260. That means we have to find the maximum moment of resistance. That means we have to find when the actual moment of resistance is equal to the maximum moment of resistance. So in which case is the moment of resistance is equal to the maximum moment of resistance, that is when is mu equal to mu limit. In case 2, that is balanced section, when the beam section is balanced. So we have to redesign the section, as its compression failure will lead to the failure that's lead to this collapse is known as compression failure, by the way, and it will happen without warning. So the maximum moment of resistance is to be calculated before collapse, that is mu limit. And in balance section, since a moment of resistance will be equal to the moment, a maximum moment, that is the maximum limit that the beam can withstand, the value of moment of resistance it can withstand or it can handle. So mu limit is equal to 0.36 xu max by d into 1 minus 0.42 xu max by d into bd square fck. We substitute the values and we get 0.36 into 0.48 into 1 minus 0.42 into 0.48. I substituted the ratio value directly. If you want, you can calculate it this way as well. 0.36 into 264 divided by 550. You can calculate the ratio value again. I have directly substituted the xu max by d value and into 300 into 550 square into 20, and we get the value as 250403788.8 Newton mm. So we found the mu limit. This is the maximum moment that this beam could withstand. When you analyze the design of a beam, if it shows over reinforced section, we have to redesign it, else what's going to happen is that compression failure will take place, the concrete will crack and collapse, and the building will collapse without any warning. If it was a tension failure, like in the under reinforced section, there's a tension failure as well. If the tensile load is more, it will show some warning before collapsing, but it's not the case in compression failure. So we have to redesign this section. There's a procedure for it. We already found the maximum moment, since they only asked about the maximum moment of resistance here. They didn't ask for it. We had to figure it out, that it was the maximum moment of resistance to be calculated. It won't be mentioned in the question. When we check out what type of section is used here, and if they mention to find the moment of resistance, we have to find the moment of resistance before collapse. It's because it exceeded that value that this collapse took place. Okay, so in case of balance sections where the moment of resistance becomes equal to mu limit, and we substituted with use this formula and substituted the values, and we got the value of maximum moment. Or we can even write it as 25.04 in 10 raised to 7 Newton mm. Fourth question. Find the moment of resistance of a reinforced concrete beam of 200 mm width and 400 mm effective depth, reinforced with 4 bars of 16 mm diameter of Fe450 steel. Take M20 concrete. Use IS code method. Redesign the beam according necessarily. So here we'll be using the procedure of redesigning. So in case if this beam has to be redesigned, or if we get it as over reinforced section. Okay, now let's look into this question. Okay, now do know the given values. Fe415 M20 and effective depth 400 mm and effective width 200 mm and with diameter of 4 bars of steel, that is 16 mm. Okay, we write the given values. The given value is beam section 200 mm into 400 mm, number of bars 4, diameter 16 mm, FCK and Fy 20 Newton per mm square, F 450 Newton per mm square for steel. We find the area of steel. We multiply the area of one steel bar into the number of bars and we'll get the area of steel provided, which is to be used in the XU by D, that is the neutral axis depth, the depth of the beam, effective depth of the beam equation. That is XU by D is equal to 0.87 FYASD by 0.36 FCKBD, and XU's value after substituting is 201.64 mm. And we find out XU max value from IS 456-2000 for Fe415 XU max or XU limit by D is equal to 0.48. XU max equal to 0.48 into 400, which is equal to the 192 mm. Therefore, XU is greater than XU max. It is a over reinforced section, so we have to redesign it, else compression failure will take place. The code recommends it has to be redesigned. So we find the maximum moment of resistance before collapse. We substitute the value and we get 88.296 into 10 raised to 6 Newton mm. Okay, we found mu limit. Why compression failure took place was because of the tensile load being more here. So that means we have to find the area of steel provided. That means if it was over reinforced, that means the number of bars used was more and it was that much number was not necessary. So that means we have to find the area of steel provided so that we can use the correct number of bars. So with the XU max by D equation, since the max, it has exceeded the maximum, so we just have to find XU max by D, 0.87 FISD by 0.36 FCK We found ASD using this equation and we get 765.76 mm square. Now we have to find the characteristic strength of steel. Because of the maximum load, there can be a variation in the characteristic strength. So with this ASD and that F, it's mentioned as actual stress, that is the characteristics that we have to find Fy, and we get it from this equation. Total compressive force Cu is equal to total tensile force Tu. We substitute the equation 0.36 FCC BXU is equal to 0.87 FYAC. This was actually the proof that I mentioned in my previous video. XU is equal to 0.87 FYAST by 0.36 FCKB. Fy is equal to point, and we substitute, we rearrange the equation and Fy comes on the left side and the rest becomes on the right side. 0.36 FCKBXU by 0.87 ASD, and it's just a slight variation in the characteristic strength, 415.0035 Newton per mm square. Okay, this is the fifth question. A rectangular beam of 20 centimeter width. Sometimes it can be given in centimeters as well as meters. Since we are using millimeters here throughout, while drawing we can convert it to mm, that is 200 mm, and 40 centimeter depth up to center of reinforcement. That means it's the depth up to the bar, that is the effective depth. It's not necessary that the question should directly say that this is the effective depth. Sometimes it can say up to the center of reinforcement. You should understand that it is up to the center of the bars, that is the effective depth. Here we have to find the area of reinforcement if it requires to resist the moment of 25 kilonewton meter here. mu is directly given 25 kilonewton meter, that we have to convert it to Newton mm, and here use M20 concrete and Fe415 steel. Okay, I draw out the given details of the question. Fe415 M20 400 mm. See this depth from the top to the center of reinforcement. From the top to the center of reinforcement is the effective depth. Here in the question it says up to center of reinforcement, so it's obvious it's the effective depth. Okay, we write the given details. Beam 200 mm into 400 mm, that's the beam section. Mu is equal to the moment of resistance is directly given. We have to find the area of reinforcement. Mu is equal to 25 kilonewton meter, that is 25 into 10 raised to 6 Newton mm. FCK and FY. FCK value 20 Newton per mm square. FY value 415 Newton per mm square. Here nothing is mentioned here, so this is actually the general equation used. It can be either under reinforced or balanced reinforced. Under reinforced is more safer because it is lesser than the maximum moment. So nothing is mentioned here. So we'll be using mu limits formulae for the under reinforced section, that is mu is equal to 0.87 Fy AST into D into 1 minus AST Fy by BD FCK. Okay, we substituted the values mu, Fy, D, Fy and BD FCK in this equation. When we rearrange it, we get it in the form of a quadratic equation: 37.45 AST square minus 1,442,0 AST plus 25 to 10 raised 6. Take your scientific calculator and solve this quadratic equation. We'll get two values. AST value is 3674.67, 181.66 mm. It is better to take the smaller value. Why? Because the spacing has to be accurate. If it's too wide or if it's placed after that, we find XU. Then we find out XU max by D into 0.48, and we see that our assumption was correct. XU less than XU max, it is under reinforced section. Nothing was mentioned here, so we directly took the under reinforced section because it's safe. But in the end, we always have to check out this first condition. Suppose it was balanced section or something, that means the moment of resistance or formulae will change. This subject is basically based on assumptions, so that is why we checked out the whether our assumption was correct or not. That is, it was XU less than XU max, which is the under reinforced section. Okay, this is the sixth question which is drawn out. This question is quite important. An RCC beam 200 mm to 400 mm is reinforced with 3 bars with diameter 16 mm of Fe415 steel. We have to find the ultimate UDL which the beam can carry safely over a span of 5 meter. Take M20 concrete. Okay, it doesn't mention about anything about the section, so but it says ultimate UDL, so it must be obviously it's mentioning about mu limit, but mu limit's value in which section? It can be under reinforced or balanced. But since they told us to find the ultimate UDL which the beam can carry safely over a span of 5 meter, we'll have to calculated when the moment of resistance is equal to the maximum moment of resistance. Okay, we write the given values: beam section, number of bars, diameter 16 mm, number of bars 3, FCK 20 Newton per mm square, FY 450 Newton per mm square, AST value we calculated and we get 603.185 mm square, mu limit is equal to, this is the formulae when it's in the case of balanced section, that is when mu becomes equal to mu limit. Mu limit's value is equal to 0.36 xu max by d into 1 minus 0.42 xu max by d into bd square fck. We multiply it and we get the value 88296652.8 or 88.29 into 10 raised to 6 Newton mm. Okay, we found the mu limit here. It says ultimate UDL. In UDL's case, bending moment is equal to WL square by 8. The maximum bending moment, the formula used for UDL, WL square by 8. Bending moment, WL square by 8. And the same as the equal to the value of 88.29 to 10 raised to 6. We have to find a value of W here, that is the ultimate load. And we get 28.25 kilonewton per meter. Now we have to check whether the assumption that we've taken is correct. We've assumed it to be balanced section, so we check out the value of xu as well as xu max, and when we compare it, 236 115.236 is less than 192. That means it's not a balanced section, it is a under reinforced section, so that means the formula changes there. So mu limits formula, or mu's formula, is 0.87 Fy AST d into 1 minus AST Fy by BD FCK 735 73545 712.6 WL square by 8. We compare it and we get the load's value as 23.53 kilonewton per meter. So that was all for today. I hope you've understood the how we find the moment of resistance and how the problems are asked in this first module. So with this video, our first module is over. I hope you've understood the first module. Any doubt, please comment down below. And I know there's a confusion for the last question, but this is how we calculate it. This subject is basically all about assumptions, and when we check the type of section, we have to check both conditions. Even if we found out in the question what the question asked for, we have to check whether our assumption is correct, in what section it is. For in this question, it was we assumed it to be a balanced section, but it turned out to be under reinforced, and hence mu limit had to be calculated again, since it was only mentioning about ultimate UDL. It's how the procedure follows for each question. Okay, so with this I would like to conclude. Thank you.